Hello, my dear students. Today, let us discuss about boiling and condensation concepts. But here, in this lecture, we'll mainly concentrate on the concepts behind the boiling. The condensation will follow in the next lecture. I'm Dr. Shrikala from the Department of Mechanical Engineering, Global Academy of Technology. Now, we all know what is boiling, right? So, we know that if we take a pan of water, keep it on the stove and supply heat. When we supply heat, when after some time the water starts boiling, that means we can see some of the bubbles formation taking place at the liquid surface. Then, if you stop these bubbles gets dissipated or it gets evaporated if you continue supplying the heat. Then if you stop supplying the heat and close it with the lid, after some time you can observe the small water particles getting adhered to the lid surface, and that is known as condensation. That means these vapors, when it is cooled, gets condensed, right? This we have observed in our day in, day out. So what is this boiling and condensation? Boiling and condensation are the phase change processes which involves the heat transfer to or from the fluid without the influence of fluid temperature, right? We observe that at these two takes place at constant temperature. But what is the heat which is coming into, which plays a predominant role? It is the latent heat which plays the predominant role. That means the change of phase occurs from liquid to vapor phase during the boiling, wherein the latent heat is liberated, and from vapor phase to the liquid phase by absorbing the latent heat known as condensation. So these boiling and condensation are widely used in nuclear reactors, steam power plants, refrigerations, air conditioning, etc. So coming to the exact definition of boiling, it is nothing but the convective heat transfer process. This involves the change of phase from liquid phase to the vapor phase. The boiling is defined as evaporation at the solid liquid interface. That means now if you consider a red hot surface or like an electric stove, we just sprinkle some water on it. Immediately after just few seconds, you can see this water starts dancing over the surface and then just gets evaporated. That means this is the evaporation which is occurring at the solid liquid interface between the surface and the liquid, the solid surface and the liquid surface. And this occurs when the liquid is brought into contact with the surface when the temperature of the liquid temperature is above the saturation temperature of the liquid, right? So boiling occurs only when the liquid has reached the saturation temperature, and then the evaporation only takes place when it reaches the saturation temperature, right? So the boiling heat flux is expressed from Newton's law of cooling, and Newton's law of cooling says Q is directly proportional to the surface area of the liquid, surface area of that, or the solid surface area, and the difference in the temperature is known as the excess temperature. This excess temperature is nothing but the difference in temperature between the wall or the solid surface temperature minus the saturation temperature of the liquid. And this proportionality constant is nothing but the heat transfer coefficient. Now, let us understand what is this pool boiling. By taking an example of water in a pan which is kept on the stove and let it be initially at around 20 degrees centigrade. Now, let us supply some heat to the water. Initially, when the temperature rises to around 30 degrees or 40 degrees, when it is far below the saturation temperature, we can see some small water particles or air molecules which are dissolved in it, just in the form of the bubbles which is observed over the pan. And these bubbles are not the actual vapor bubbles, since its temperature is far below the temperature of the below the saturation temperature. So these are not the vapor bubbles, these are the air molecules which are dissolved in the water. Now, further supply heat. When further heat is supplied here, you can see here in a schematically, these the small chunks of water starts rolling up and down by the natural convection. Further, if we supply heat, we can see the bubbles formation taking place on the surface, liquid solid surface. That means it is on the bottom surface of the pan. These bubbles starts rising up because these bubbles gets the energy and becomes lighter and starts rising up over and starts rising, and then these bubbles pushes the heavier cold water particles on the upper surface and pushes downwards. So that way, in this way, the rolling of water or the way bubbles starts rolling up and down due to the natural convection. This is known as buoyancy. So these bubbles detached from the surface starts rising and gets collapsed, again comes down. So this is known as subcooled boiling, wherein here the temperature of the liquid has not reached the saturation temperature. Now, with the further increase in the supply of heat, this bubble formation increases, rises, and reaches the top surface and breaks away at the top surface and gets released from the surface. This happens when the water is completely saturated, and this type of boiling is known as saturated boiling. So this complete we call it as pool boiling. Now, let us see different forms of boiling. There are two forms of boiling. One is the pool boiling and another one is the forced convection boiling. In pool boiling, as we see, the bubble growth and as well as the dissipation or the bubble movement or rolling up takes place, and detachment and bubble growth and detachment takes place by natural convection only. Whereas in forced convection, the water it will be forced into the water tube boilers and by external means. That means we are pumping the liquid and forcing the flow of the water. That is forced convection boiling. These pool boiling and forced boiling are further classified as subcooled boiling and saturated boiling. And we have seen already what is subcooled and the saturated boiling. Subcooled boiling means you can see here the schematic shows, right? So when the temperature of the water is showing as 80 degree, it is less than the saturation temperature of the water. So the water at 1 atmospheric pressure, the saturation temperature of water is 100 degrees centigrade. So when the temperature is below saturation temperature, then the boiling is known as subcooled or the local boiling. And here in this case, the bubble formation takes place along the surface of the liquid and gets rises and dissipated in the water itself. That is water entrainment, bubble entrainment. So these bubbles travel some distance and gets dissipated or gets condensed in the liquid itself. The other one is the saturated at the bulk boiling. In bulk boiling, the water bubbles or the vapor bubbles formed on the surface of the solid surface forms a column, gets rises up, and due to the buoyancy effect it rises up and escapes from the liquid surface. This occurs when the water temperature is saturated temperature. That means at 1 bar pressure, saturation temperature is of water is 100 degrees centigrade. Okay, now let us see how the boiling occurs, or what are the different phases of boiling when a heating element or when a hot surface is brought in contact with the water which is at saturation temperature. That means you can see here, this is the heating element which is at a temperature higher than the saturation temperature of the water. And how the boiling occurs is shown in a curve by known as the boiling curve. This is nothing but the representation of the heat flux versus the excess temperature. What is excess temperature? This is nothing but the difference in the heating surface temperature. Ts or Tw both are same here. That is Tw and Ts both are same. Wall temperature or the surface temperature minus saturation temperature of the water. So this excess temperature. So curve is drawn between the heat flux versus excess temperature. Now, initially, consider a heated platinum wire submerged in a pool of water. So consider a pool of water and the platinum wire which is having a temperature slightly above. Initially, let the temperature of this heating element be slightly above the saturation temperature. Let us see the different regimes of boiling when heat supply is increased, or the heat flux to the heating surface is increased steadily. Initially, when the difference in temperature is some within 5 degrees, that is the heat flux supplied in such a way that the temperature difference between the heating element and the water temperature, that is 100 minus, sorry, this 100 would be 105 somewhere. So when this temperature difference is within the 5 degrees, then the evaporation takes place at the surface of the solid and the liquid. Here the evaporation, small evaporation takes place, and here during this evaporation the bubble formation will not take place, and only the small chunk of water gets evaporated and dissipated in the water itself, rises and pushes the cold water particles downwards, and that way the free convection currents occur when the temperature difference is within 5 degrees centigrade. So that phase is known as interface evaporation or the free convection. Here the heating element will be slightly superheated compared to the water surface temperature. Now, further increase the heating element temperature. When the heating element temperature goes in excess around for 10 degrees centigrade, the small bubble formation takes place on the surface. These bubbles rises up and gets condensed in the water itself. These bubbles will not reach the water surface. That phase, and these bubble formation takes place at certain locations on the heating surface known as the nucleation sites. That locations where the bubbles initiates on the heating surface is known as the nucleation sites, and when these bubbles rise and gets condensed in the water, that is nothing but the nucleate boiling of in this phase 2. That means this nucleate boiling consists of two phases, 2 and 3. In the first phase, the bubbles gets condensed in the water. With the further increase in the temperature, the more bubbles starts coming out, and these forms a column of bubbles over and rises to the liquid surface. At the liquid surface, it breaks away and gets dissipated. This when the Texas temperature reaches up to around, when this temperature delta T goes up to somewhere around 50 degrees centigrade, the heat flux will be maximum. That with that point, and there will be high steep increase in the heat flux and becomes maximum at this point. This point is denoted by A, known as the critical heat flux. This critical heat flux is nothing but the maximum heat flux which occurs in a during boiling. Beyond this point, the trend of this changes. More than that, beyond this point, the boiling becomes unstable, and many a times the heating element the starts gets damaged and starts melting away beyond this critical flux. Hence, always for safe working, this heating element or the heating coil will always be maintained within the critical heat flux. Now, next further increase the heat supply. When the further increment in the heat supply, the trend of increasing trend which we have observed in the during the nucleate boiling is completely reversed here, and the boiling becomes unstable because these bubbles, there is a rapid bubble formation takes place, and these bubbles blanket the surface and covers most part of the heating element. Can you see here the film boiling where it is blanketing? That means complete the surface starts getting covered with the liquid or the vapor. This vapor surface is the conductivity of this vapor surface is very low. That means it acts as an insulating material. The vapor film which is formed over the heating surface acts as a insulating material and prevents the further liquid in coming in contact with the heating limit. Thereby, the heat flux reduces. And in during this the first stage of the when the temperature is below 150 degrees centigrade, the boiling condition will be unstable and it will be oscillating between nucleate boiling and film boiling. The oscillation takes place between nucleate and film boiling. With the further increment in the temperature of the heating element, when this becomes boiling curves, the heat flux becomes minimum because this is due to the fact that more bubble formation takes place and forms a liquid film, completely blankets the surface, and it becomes stable and blankets the film surface, so that the outer liquid has to reach the heat element, it has to conduct through the film thickness. So here the convection will not come into factor, mainly the conduction comes into factor, because this covers the layer of the thin film, covers the complete heating element, and it becomes stable. So when and the heat flux becomes the minimum, and that minimum heat flux is known as the Leidenfrost point. When the then further increment in temperature, heating coil temperature, wherein at very high temperatures the radiation becomes a predominant factor, and radiation comes into factor, and all the heat dissipation from the heating element takes place by predominantly by radiation. Hence again the heat flux increases at very high temperatures. This is known as the boiling curve. So the film boiling consists of three phases. Initially, it is unstable film when it is below 150 degrees centigrade. Then the film completely blankets and comes and forms a stable film. And with the further increment in temperature, the heat flux increases and the radiation comes into play. That means the heat flux or the takes place only by radiation at very high temperatures. When it is around delta T, when it goes beyond 1000 degrees centigrade. So these are explained here. Three phase and mainly three regimes: interface boiling, nucleate boiling, and the next is the film boiling. Interface boiling, it is nothing but the free convection zone. Delta T is around 5 degrees centigrade. and only free convection takes place in the first part, and the next is the nucleation, second and the third phase. In the second phase bubble forms, gets dissipated in the liquid without reaching the liquid surface, but in the third one they reaches the liquid surface and gets dissipated on the lead reaching surface. Here the large fluxes are obtained. This is mainly because of the combined effect of liquid and the entrainment and the evaporation. So normally the nucleate boiling exists up to the delta T of 50 degrees centigrade, and the maximum heat flux known as the critical heat flux. And what is the order of the heat flux? It will be around 1 megawatt per meter square with the order of heat flux, and beyond this point metal gets damaged. Hence it is always equipment is used within the critical heat flux point. And the last one is the film boiling. As I said, when it goes, so normally in the film boiling we have three stages. Stage 4 where it is unstable boiling, and in unstable because the it blankets the surface, the most part of is blanketed, and the heat takes place, heat flux takes place by conduction, and the conducting oscillates between nucleate and film boiling. And further increased temperature, film gets stabilized, completely covers, and only by conduction the heat flux has to reach by only by conduction, and the least heat flux is known as lead and frost point. And with further increment in temperature, film becomes stable, and significant portion of the heat is lost by radiation only. Thank you.